Dear students, welcome to YourPedia. This is Shyam Sharma, who taught measurement subject for almost 12 years. Let us see an important design in the measurement subject, which is ammeter design. Come on, dears, where we use this ammeter? Ammeter is used for the measurement of what? Current. Correct? Ammeter is used for the measurement of current. Simple question here, sir. Why we have different ranges of ammeter? What scenario has demanded to manufacture different ranges of ammeter? Let's have a look into that. So technically, PMMC instrument can be represented like this. Technically, PMMC instrument can be represented like this. What is PMMC, sir? Permanent magnet moving coil instrument. So this is not current source. Please don't feel this as a current source. This is a meter. Here you can see the scale. Arrow mark is crossed and even the scale is marked. Now I am putting here internal resistance of the ammeter. Internal resistance of the ammeter. Fine, sir? Right. So please remember one design point here. PMMC instrument, current passes through the springs. In PMMC instrument, current passes through the springs. Hope you are aware of this. Now here, one important point. By using PMMC instrument, we can't measure high currents. Why? Come on, sir. By using PMMC instrument, why we can't measure high currents? Because if you send high currents, springs are the current carrying conductors, springs will damage. If you send high currents, since springs are the current carrying conductors, meter will damage, springs will damage. That is the reason I can't send high currents in PMMC instrument. For that, what I have to do? Come on, sir. If one way is not allowed, what do you do? You look for other way. The similar way here, this way is not allowed. Therefore, what we have to do is we have to bypass that current. So now, please, let us say maximum allowable current in the PMMC instrument is IM. Let us understand like this. Where IM called as meter current. Meter allowable current. Similarly, maximum voltage where my meter can measure is VM. Let us feel as measurable voltage. Okay, sir. Now, what is your intention, sir? Design of ammeter here. My discussion started like this. Why we require different ranges of instrument? So now, please. Now here, now I want to measure some capital I current. I want to measure some capital I current. So please understand, this I current is very much greater than this IM. If I current is directly sent through this meter, what happens, sir? Just now I said, springs will damage. Springs will damage. Now what do you have to do? We have to bypass this current. Come on, guys. Now I want to bypass this current. Okay? Yes. Now I am connecting this resistance in parallel to this. That's why this resistance we call as shunt resistance. What resistance, sir? Shunt resistance. RSH. One beautiful objective question asked in HPCL. Come on, sir. This RSH value, is it less than this RM or more than RM? RSH value is less than RM or more than RM, sir? It is less than RM. Reason? Compared to this current, IM current, this I current is more. When more current is coming here, obviously this resistance should be lesser than this resistance. So very first objective question what I can conclude is RSH is less than RM. Okay, sir. Now from here your networks comes into picture. Observe carefully, sir. Apply KCL and tell me. Just a second. Yeah. Right. So please apply KCL and tell me how much current flows here. A second, sir. Yes. How much current flows here? I minus IM flows in this branch. I minus IM flows in this branch. Simple KCL. Now IM is coming like this. I minus IM coming like this. Please tell me what is this current, sir? I minus IM. Now what is the current here? IM. Now total current adds to what, sir? I. Total current adds to I. Now observe carefully. Now our interesting analysis is here. Come on sir. What is this I? Current which you want to measure. What is IM? Current which meter can take. If you send high current as you wish, springs will damage, meter will damage. Hope you remember a number of times in your college labs, might be by some reason, by some mistake, by some miscalculation or by some misconnection, the meter would have been burnt. Do you remember? Right sir. So here finally I current is coming out. Yeah, our analysis is here. Come on, tell me guys. So this is just a meter. This is just a meter. Please don't feel this like a current source. See, if you feel this like current source, you'll feel like some voltage exists across this current source. No sir. You can feel voltage across this as simply as 0 volts. Okay sir? Fine. Now tell me how these two connected? In parallel. In parallel what is same sir? Voltage is same. Come on, what is this voltage? Similarly, what is this voltage sir? Right. IM into RM is this voltage. IM into RM is this voltage. Similarly, tell me what is this voltage here? How much current is flowing? I minus IM into RSH is this voltage. Current is I minus IM. Voltage I want. I minus IM into RSH. I minus IM into RSH. So why I am doing all this? Why I am doing means, so no, I want to measure this current. My intention is to measure this current. If I send this current to this meter will damage. Why? Because springs are the current carrying conductors. Further, what I am doing here? I am bypassing this excess current by connecting a shunt resistance. What value of shunt resistance has to be connected to manufacture this meter to measure this capital I current range? Get the point please? Right sir. So here finally the RSH value is what? Just manual calculation. RSH equals to, come on, IM into RM divided by, come on, I minus IM. Please have a look. Now observe carefully sir. Please take this IM as common, further extension. RSH equals to, if I take IM common, what I get? IM into RM by, taking IM common, I by IM minus 1. So what gets cancelled? IM gets cancelled. Come on sir, what is RSH? Come on guys, RM by, this I by IM we call as M, multiplication factor. Multiplication factor dears. This M we call as multiplication factor. Okay, right. Further I am writing this as M minus 1 over. Ammeter Design is ready sir. What value of shunt resistance has to be connected? RM by M minus 1. To calculate RSH, what data has to be given? Meter resistance has to be given. Allowable current has to be given. What is the value of current which a customer is supposed to measure has to be given. Then you will be getting the answer. Correct? See, just whatever the formula I have, from that formula, how many subsequent formulas I derive now? So the very first formula which we have derived, RSH equals to RM by M minus 1. This is what we have derived. So no rocket science here. Just two elements or two resistors are connected in parallel. We have equated the voltages and we got the required value here. Next, what is M sir? What is M? I by IM. So I want to elaborate this. What is this I actually? What is this I actually sir? What is I? Required current. Required current means current which you want to measure. Required current means what sir? Current which you want to measure. What is this IM? Available current. available current. Hope you got the point. Next, from here, sir, can you tell me what is M from this formula? M from this formula, third formula which I am deriving, M minus 1 equals to Rm by Rsh, correct? What is M from this, guys? 1 plus Rm by Rsh. N number of times this question is asked in HPCL. Okay, right. M equals to 1 plus Rm by Rsh. How many formulas you have for M? 2 formulas derived. The very first one, I by Im. Please don't get confused. Some says Im by I. No, dears. Options are available. Im by I by Im, something like that. You should not get confused. Okay? That's why I'm saying, what I'm saying, sir, required current by available current. Bigger current by smaller current. This M we call as what? Multiplication factor, which is a higher value. Multiplication factor. Okay? Fine. Next, still what questions we can write, sir? Let's go to the previous slide. Please have a look. Still what analysis we can do here? Sir, can you tell me what is Vm? Can you tell me what is Vm? Im into Rm, correct? Im into Rm. What is the Vm also equals to? I minus Im into Rsh, correct? Let us also write that equation. Number 4. Yeah. Vm I can write as Im into Rm, which is also equals to I minus Im, second, I minus Im into Rsh. Correct? Correct? So one more point. Can you look at this structure and tell me still what analysis we can do here? One interesting point is also there. Lastly, one important point is also there. What is that? Come on, sir. See, so now, earlier my meter is having a resistance of Rm. Whereas now, after connecting RSH for measuring this I, my complete meter has a new resistance. My complete meter has a new resistance. What is that new resistance? What is that new resistance, dear? Looking from these terminals, what is that R new? What is that new resistance? Come on, tell me please. Looking from these terminals, how these two resistance connected? In parallel. So I am writing the next slide. This R new equals to new meter resistance. R new. New meter resistance is what? Rm parallel Rsh. Having any doubt? Please have a look. Tell me how these two resistors connected in parallel. Rm parallel Rsh. So just we have done the analysis. Now let's have a look at one question and see how we get the answers simply. Okay? Right. Let me write one question on my own. A 0 to 1 milliampere, a 0 to 1 milliampere PMMC instrument with internal resistance of 100 ohms, with internal resistance of 100 ohms is used to measure 10 milliamperes. Design the meter. Don't feel this like a designing question. No. In this question, see how many sub-objective questions I will derive. Okay, sir? Fine. Design the meter. Come on, guys. Please have a look at the data and tell me what is available here. Yes, a 0 to 1 milliampere PMMC instrument. What is PMMC, sir? Permanent magnet moving coil instrument. What is the meter range that is available? 1 milliampere. What is the internal resistance of the meter given? 100 ohms. 100 ohm internal resistance is given. So please have a look into the design point which I have discussed earlier. What data is supposed to be given? As I said earlier, IM has to be given and RM has to be given. Exact that is given. And now examiner is asking to extend to what range, sir? Is asking to extend to what range? 10 milliampere range. 2 currents, 1 resistance has to be given. It is perfectly given here. Now let us analyze this. One milliampere range. One milliampere with internal resistance of 100 ohms. Now I want to extend to what range? Yes, 10 milliamperes. Now you tell me, if I send 10 milliamperes, what happens? I want to send 10 milliamperes. Can I send 10 milliamperes directly? No. Why? Springs are the current carrying conductor. Springs will damage. That's it. Now what you have to do, sir? As discussed earlier, you have to bypass this current. To measure this current, I have to bypass this current. Yeah, connecting some resistance, RSH. Come on guys, tell me, how much current flows here? 9 milliamperes. 9 milliamperes. Here what is the current? 1 milliampere. Both adds like what? 10 milliamperes. Perfect. Network is over. Now we have to find what, sir? This RSH value. Come on, how these two connected? Parallel. In parallel, what is same? Voltage is same. Okay? Or directly you can also apply the formula. RSH equals to what is the formula, sir? RM by M minus 1. What is RM? 100 ohms. What is M? Required current by available current. Please have a look. What is required current? Required current is 10 milliamperes. Whereas available current is what? 1 milliampere. Required current is 10 milliamperes. Available current is 1 milliampere. Now what is M? Required current by available current. 10 milliamps by 1 milliamp. How much? It is 10. So here M I am putting here. Required current by available current minus 1. Finally, what is the answer, sir? 100 by 9. These many ohms. 100 by 9. These many ohms. This is what the RSH value. Okay, next. What question can be asked? Extension point. What question can be asked? What is meter voltage, or what is the maximum voltage that meter can measure? So now here 1 milliamp is flowing. What is the voltage that can be measured, sir? 1 milliamp into 100, how much? 0.1 volt can be measured. That's it. By using this meter, what is the voltage that can maximum measured, sir? 0.1 volt. Fine. Next, what came the question that can be asked, sir? Other practical questions, possible questions? New meter resistance. New meter resistance. What is available meter resistance? 100 ohms. 1 milliampere meter resistance is what? Given as 100 ohms. Now I am asking, what is the resistance of 10 milliampere meter, newly designed meter? So here, R new, VM we have already calculated, 0.1 volt. What is R new? Or what is resistance of 10 milliampere meter? How much, please? How these two connected, sir? Parallel. Means what? 100 parallel RSH. Here simply 100 parallel 100 by 9 ohms. That's it. Just to calculate, you will be getting the answer. Is it done? Right. So here one important question. how the scale is calibrated. With this scale calibration, I'll conclude this topic. How the scale is calibrated. Why we are having different ranges of meter. This is what the question I have started with. This is what the beautiful question asked in a number of interviews. Let us start analyzing that. So, you tell me, what is the scale that is available for us? What is the meter that is available for us? 0 to 1 milliampere meter, correct? The scale of the basic PMM's instrument is like this. 0, 0.2 milliamps, 0.4 milliamps, 0.6 milliamps, 0.8 milliamps, 1 milliampere. Okay, this is what the basic scale that is available. Now I want to extend this to what range? What range, sir? 0 to 10 milliamperes range. Okay, right, just a second. Okay, yeah, so it will be having equal spacings, okay, equal spacings, right, because PMM's instrument is a linear instrument, scale is linear, equal spacings, equal spacings. Right, sir? Right. So now please. So now, how we measure 10 milliamperes? See, when I have 1 milliampere meter, when the scale is designed or manufactured for 1 milliampere range, how 10 milliamps is indicated? So now please. The scale, available scale has to be multiplied with M. Has to be multiplied with M. What is M, sir? Multiplication factor. What is M we got? 100. Whatever the existing scale you have, you please multiply that scale with what? 100. So now this will be what? 0, 0 into 100. 0.2 milliamperes into 100. How much, sir? 2 milliamperes. 2 milliamperes. 4 milliamperes. I think M is not 100 years. M is 10, right? M is 10. Why M is 10? I want to extend to what range? 10 milliamperes range. M we have clearly written here, sir. M is just 10. 10 milliampere by 1 milliampere, M is 10. Okay? Yeah. It has to be multiplied with 10. 2 milliamperes, 4 milliamperes, and here 6 milliamperes, 8 milliamperes, and lastly 10 milliamperes. Please note, sir, M is 10, not 100. Okay, fine. Now, this is what the new scale that is available for us. How the scale is getting manufactured, how the scale is getting printed, sir? For available scale, manufacturer, he is multiplying the existing scale with a multiplication factor so that new scale is getting ready. Now observe one interesting point. You are sending 1 milliampere or say you are sending 10 milliamperes. How much current is getting into the meter? 1 milliampere is getting into the meter. When 1 milliampere is getting into the meter, my meter indicates what? My meter indicates 1 milliampere like this. Once my meter indicates 1 milliampere, by default what value is indicated, sir? 10 milliamperes. So soon I give a point. Sir, usually manufacturer will be having basic PMM's instrument in his godown. Customer will come and ask, I want 10 milliamperes meter, I want 100 milliamperes meter, like that. Once customer comes and asks the required range, manufacturer will open his measurements notes and he will see what is the formula for RSH. RSH, Rm by M minus 1, that much resistance will manufacture first and he will connect that resistance in parallel to the meter like this. And whatever the scale that is there, earlier scale, that scale, what he do, sir? Available scale, this scale, he multiplies with multiplication factor and he manufactures and he prints new scale. So now what's happening, sir? Tell me, when you're sending 10 milliamperes, 1 milliampere is flowing to the meter, that is indicated 1 milliampere. For 1 milliampere, the indication is this, but in place of this 1 milliampere, now what is printed, sir? 10 milliamperes is printed. Hope you got the point. Manufacturer will erase this scale, these points here, 0, 0.20, he will erase. He will print new values and he gives to the customer. My simple question to you, sir, really is my meter measuring 10 milliamperes? No. Measuring how much? 1 milliampere. Indicating how much? 10 milliamperes. Hope you got the point. Measuring 1 milliampere, indicating 10 milliamperes. Is this done? Right. Next, one more point here. One more interesting point. Please observe carefully, sir. Suppose if I send, let me use some other color pen for bifurcation purpose. Yeah. Suppose if I send 6 milliamperes. Interesting analysis is here. 6 milliamperes. Usually students think like this. This will take maximum current of 1 milliampere and meter will go and stop at, pointer will go and stop at 1 milliampere again. And here 10 milliamps is there, na sir. Students will be feeling a bit confusion. But this is not correct, sir. Reasons, no. Just networks. When you are sending 6 milliamperes, this current divides between this 100 ohms and this RSH, and how much current flows here, sir? 0.6 milliamperes flows here. Once 0.6 milliamperes flows here, my pointer deflects for 0.6 milliamps and stops here. Come on, tell me, in place of 0.6 milliamps, what is printed? 6 milliamps is printed. Now similarly, if 4 milliamps is sent, pointer comes and stops at 0.4 milliamps. But in place of 0.4 milliamps, 4 milliamps is marked. Hope you got the point, yes. So this is how manufacturer will calibrate the scale. Hope you got the points here. If I summarize, PMMC instrument, yes, it can't allow high currents. Reason, springs are the current carrying conductors. Why we have different ranges of instruments? This is the reason, yes. Springs, yes, that is the problem. Okay, right.